A very warm welcome today from sunny Dublin. It's a minute past the hour now, so we're going to jump right into how service providers use disaggregated cell site gateways to build flexibility into their network with UfiSpace. This is the latest episode in our webinar series, It's Open Networking. You can access our past webinars and our future webinars here on our Bright Talk channel. My name is Ciara McCarthy. I'm the Global Marketing Director for EPS and I'm based in Dublin. But we pretty much have the globe covered today with attendees from all across the US, Europe, Africa, the Middle East, India, Taiwan, and the Philippines, to name but a few. Céad Míle Fáilte, that's a welcome in Irish, and thanks for joining us today. So I wanted to start by painting a picture that you might recognize, and then I'm going to hand you over to the experts. So does dealing with multiple vendors cause you hassle? I imagine that you're all very busy and having to source your network gear from several companies and all of the admin involved in chasing up orders and managing shipments that are arriving at different times is frustrating, and it eats away at your precious time. EPS is here to help. So we specialize in open networking solutions, superior customer service and logistics. You can check out some of our customer testimonials in the attachments tab here on Bright Talk also. So it's our job to make your life easier. We hold stock and we can ship switches, servers, optics and cables to you in consolidated shipments, and they'll be preloaded and configured with your choice of open software from any of our 28 global locations. Not only that, we provide the tech support you need from when you're doing the research phase all the way through to your project deployment. So that brings me nicely into introducing our speakers, starting with Barry McGinley, who is our system engineer based here in Dublin and is the person who would be providing the first layer of tech support to you in EMEA. Our colleague George Say is his counterpart in North America, and Chetan Chowdhury in Asia. So we can support you wherever you're located. Barry works on proof of concepts for data center, service provider and enterprise deployments, and he leads the adoption of new bare metal hardware for carrier and telecom solutions. Barry has in-depth expertise on the disaggregated networking landscape, covering all of the open source software and the hardware available. He has a Bachelor of Science in Networking Applications and Services from TU Dublin and a Master's in Cloud Computing for CIT, excuse me. Joining us also today is Ray Chang from UfiSpace. Ray serves as the Director of Research and Development at UfiSpace, where he leads the planning and development of carrier grade 10 gig, 25 gig, 100 gig and 400 gig switch and router product architectures. Ray has a Master's in Electrical and Control Engineering from the National Chiao Tung University. I hope I pronounced that correctly, Ray. Ray is based in Taiwan, and we're delighted to have him here virtually meet with us today. So with that, Barry, can you tell us how are telcos building flexibility into their network?
Okay, thanks for that, Ciara. Yeah, so telecoms, data centers, they're all building flexibility into their network using disaggregation, basically, or open networking, or SDN. It has many names. So I'm going to explain some of that now in a moment. So just a little about EPS before we get into it. So EPS has been involved in open networking or disaggregation since 2013. So we started with the hardware partners and realized pretty quickly that the hardware was only one part of the solution. So we went out there and we started evangelizing about open networking and also build relationships with the NOS vendors. So they're the network operating systems, and you'll see them on the bottom left there: Pluribus, Sonic, IPI, IP Infusion, Exaware, Volta. There's plenty of them. So we have relationships with all the software guys, and what we like to do is take some of the hardship out of open networking. And what I mean by that is it can be a little daunting looking in at so many different operating systems and so many different hardwares, but we can help you on that journey. So we can get trial licenses we can test multiple softwares. And then what we do as well for the software vendors and our customers is load the software onto the boxes and then load the licensing onto the boxes and then ship so they're ready to slide into racks or into central offices, and then bundle in transceivers and so on and so forth. So it takes a little of the pain point out of open networking. So I'm going to do a little on the history of open networking, or disaggregation, or SDN. As I said, you'll hear many names for it. I think telecoms at the minute love the disaggregation name. So to start with, we'll go back to 2008 and the creation of the OpenFlow protocol. So this was created in Stanford University, and it allowed for the separation of the control and data plane. So basically the control plane had access to the forwarding plane of the white box switches. 2010, this kind of started, I'm not going to go into all the history of it. This kind of started with Facebook deciding to redesign their entire network. So they went off, they redesigned the servers, the switches, the power supplies, cooling, everything. That data center is still operational in Primeville, Oregon. But what happened from this was themselves, Rackspace, Goldman Sachs and a few others decided to create the OCP, that's the Open Compute Project, which was going to look after the hardware side of things. At the same time, the ONF was created, and they were more involved on the OpenFlow side and looking after protocols and what the definition, I suppose, of what SDN, software defined networking, was at the time. Moving forward to 2016, and in 2016, the Telecom Infra Project was created. You'll see the icon down there at the bottom. And this was obviously focused on telecoms. And at the same time, the ONF, the Open Networking Foundation, kind of changed tack, and they decided to look more at telecom solutions. So then moving forward to 2019, and the projects and the products from 2016 are now starting to be deployed with major tier ones. And that's where we are now. Obviously, the last year, things have been a little slower, but there's still been major deployments. So that brings us up to 2021. Okay, so what are the actual benefits of disaggregation or open networking? So the first one is no vendor lock-in. So you're not at the whim of Juniper and Cisco anymore. Flexibility in the central office and data center design. So we've changed data centers anyway, is now a cluster topology instead of the 3 layers we used to have. The software scales separately from the hardware, and this is something that's really important. So before, maybe it took 16 months, 18 months for a new switch to come out. Obviously, the software scales a lot quicker than that. So separating the two allows the software to improve on a much faster basis. The use of merchant silicon. So obviously Broadcom has I think over 80% share of the market, but we now have Marvell and a few other guys coming in. But using common off-the-shelf switches with merchant silicon obviously makes things a little cheaper. It's easier to scale these networks. Just from the data center point of view, if we're oversubscribed, we had a spine switch, and if we need more port density, we had a leaf switch. And as I said, these can be sitting on a shelf ready to go. And there's CapEx and OpEx savings, which everybody likes. There's a CapEx and OpEx trade-off. If you want to go for solutions, say for the data center, like Cumulus, you're still individually managing these boxes, so you get a lot of capital expenditure savings. But then if we were looking at adding in something like Pluribus, where you can manage the entire network or multiple fabrics, or Abstra, which is like an orchestration layer, you're going more towards the operational expenditure saving side. Okay, so where are we seeing telcos move into this space? So the first one, it was a proven formula. So they saw the hyperscale data center guys, so Google, Facebook, Amazon, Microsoft, they're all using bare metal, and in most cases their own operating system. So for Microsoft, it's Sonic, software for open networking in the cloud, and for Facebook, it's FBOSS. And then obviously since that was 2013, 2014, and since then, it's become mainstream to use bare metal and a network operating system. Disaggregated routers deliver true savings compared to incumbent models. So I'll mention them, Juniper and Cisco, huge savings. Technology and hardware, both hardware and software are now mature. So as I said, we've been deploying, the hardware has probably been around since 2017 and 2018. We've had the Broadcom ASICs, so their DNX range, so Qumran, Jericho, Ramon, we've had these a good while now. And the software we always get the hardware first. The software is now mature. So since 2019, there's companies out there, IPI, DriveNets, and so on, that have been working in networks for 2 years. So rapid innovation and new services by leveraging container-based microservices. So when we look at a company like DriveNets, each individual routing application is in a container, so we can actually use the resources properly. So use the resources in the switch properly, and we can bring down whichever routing service we actually want due to containers. Okay. So I just wanted to, I mentioned the telecom infra project and the ONF and the way they changed in 2016. So just to look at one of the projects, because I think it's quite interesting that they're looking at end-to-end solutions rather than just individual boxes or an individual piece of software. So this is just one project from the telecom infra project. It's called the OOPT, or the Open Optical and Packet Transport. So we'll run through it. Our users on our mobile phone, and they have a radio wave to the mast. So it's down into the baseband unit. And I think Ray is actually going to go through the different scenarios with the distributed unit and the centralized unit, and where we can actually sit the cell site gateway. But from a just looking at it from an end-to-end solution point of view, into our cell site router, multiple cell site routers into our aggregation router, down into our optical transponder. And these are all bare metal white box solutions, muxed, amplified, demuxed, and then back to our core. And basically we have every device here now as bare metal or white box, a white box solution. Okay, and why should we begin at the cell site? So I suppose this is more appropriate for what we're talking about today. So it's immediately required. So I think the majority of stuff out there is 1 gig. And obviously for better 4G and certainly for 5G, that's not enough. So these boxes have to be pulled out. It's easier to start small with minimal investment. So you can upgrade on a ring basis and just small amount of devices, small amount of investment. Traffic pattern is similar. It's simpler, I should say, than other parts of the network. Need to be ready for the timing requirements of 5G and prepare for backhaul capacity for the future traffic volume. Okay, so just to finish up real briefly, where EPS sits. So EPS sit in the middle as a master distributor. We have relationships with the hardware vendors and then our software partners. And then we distribute that to the resellers and sometimes to the end users themselves. So now I'm going to hand you over to Ray to take you through the cell site gateway in a bit more detail.
Okay. Thank you, Barry, and thank you, Sarah's introduction. So, hi everyone. My name is Ray. I'm the director of UFI-Space. After joining UFI-Space, my focus was turned toward building 5G white box solutions for cloud and carrier service provider. And before, I mainly worked on the data center solution for OEM customers. So just a brief history of UFI-Space. We started in 2012, and in 2017, we transitioned our effort toward open disaggregation. In 2019, we launched our disaggregated cell site gateway, which was based on AT&T's OCP specification contributions and tailored to TIPS specifications. It's said to be the industry's first DCSG to be deployed in a live traffic environment. Since its launch, we have shipped tens of thousands of units, and we are coming up on 100 million accumulated service hours. In 2020, we launched our disaggregated open router solutions, which was designed as a distributed disaggregated chassis. This is the world's first disaggregated open router to be deployed into the network of a major carrier. Here we are using a uniform hardware architecture to enable services at both the core and edge networks. But today, we are going to focus on the DCSG, so we will leave the DDC for another day. This year, our goal is to expand on our solution offerings and provide more options for our customers to adopt open disaggregated architectures. One thing that sets us apart is our heavy focus on R&D, sales, and marketing. We actually work with world's top EMS manufacturers, Foxconn, to ensure product quality. This gives us more resources and time to focus on our customers, be it developing the latest innovations or ensuring that our solutions will actually solve our customers' pain points. Another very important focus of ours is that of our ecosystem. Disaggregation isn't done by just one party, so we strive to enable more efficiency along with our partners. We work with silicon vendors, node partners, and system integrators to create a solution that is geared to help our customers create more value with their network. Our first use case is from our DCSG deployment with one of the North America's top carrier. It was really just good timing for us. They were planning to upgrade their current cell size and preparing them for 5G at the same time. They were facing a surge of data from their customers' evolving uses of the internet. For example, on-demand video was on the rise and their old equipment was having a hard time keeping up. They wanted to go the open disaggregation router because of all the reasons Barry mentioned, so I want to go too deep into that. Versatility, flexibility, reliability, and of course, there is the savings to CapEx and OpEx. So our DCSG was a two birds, one stone solutions for them. They could update their CSI gateways to meet the growing data demands on their network and enable their CSI for their 5G rollout. Our S9530XS was a perfect fit. We had a multitude of ports ranging from the 100 megabit per second all the way up to 25G and 100G. This allowed our customer to deploy one box at the cell site to support their old and new equipment. Well, technically, it wasn't one box at a site. There was at least two for redundancy. I know the drawing here shows one, but it's just to show you where our DCSG fit in the scene of things. There were actually two DCSG per cell site connected in redundancy for over the operation without any issue happens. The network deployment looks really simple, and that's because with tens of thousands of cell sites to manage, it cannot be too complicated. Otherwise, you are going to spend a fortune in servicing. For our customer, it wasn't just that we had to make a reliable disaggregated cell site gateway, because the CapEx was only a part of the overall costs. The capability of our DCSG to reduce their OpEx was a major aspect as well. For example, one of the major considerations brought up by our customer was how to efficiently diagnose and service the equipment. Because some cell site locations may not be very easy to reach by conventional means of travel, In some places, it was a huge cost because they had to dispatch helicopters in order to reach it. So they need a cell site gateway that was not only easy to install, but reliable enough to reduce service visits. And in the case there were problems, they could diagnose or reboot remotely. That's why all of our DCSG was designed with onboard BMC. A BMC is a baseband management controller, and it allows for remote monitoring and control of our DCSG. With our partners' node system, they can set up a warning or provide equipment diagnosis through this BMC chip with our comprehensive BMC firmware. Another one of their major pain points was they had a lot of outside cabinet. And outside cabinet was basically a small enclosed metal box where you will have a limited amount of space and power to installing equipment. It's different than indoor ones where you are sitting in a room with actually enough space and the technician had access to both front and back of the equipment. In the outdoor plane, their main access was from the front. So our DCSG were all designed with everything front facing. They could access all the ports, timing interfaces, and power supply from the front. With everything we have learned from this deployment, we have been able to help our other customers deploy more successful DCSG solutions. We are able to help them through a lot of more routine deployment issues so they can focus more on their service applications. Another use case, we deployed the DCSG with a major telco in Taiwan. This deployment application was a bit different than our previous ones. In the last one, they were upgrading their cell site equipment for 4G and enabling 5G at the cell site. In this use case, we were building out a 5G network for enterprise customers. So instead of updating their old equipment, they wanted to extend their network, but doing so without affecting their existing LTE network. Their network was built in rings, with the core aggregating several 10G hub rings, and their hub rings aggregating a bunch of 1G access rings. The access rings are the nodes where they could connect with their customers. They had a grandmaster clock at the regional core, which could act as the timing source for that region. This was fine and all for 4G and even the 5G backhaul, since according to ITU, the requirement are plus minus 1.5 microseconds for the entire transport network. But at the cell site, it's a different story. The timing requirements for 5G services were much more stringent. 250 nanoseconds for carrier aggregation, 65 nanoseconds for MIMO, massive in, massive out, and 10 nanoseconds for provisioning if you are talking about 3-meter accuracy. So the timing source all the way at the core was not enough to meet the requirements at the 5G cell site. Timing synchronization would be critical for some applications. As you may know, Taiwan has a big manufacturing industry, and those machines move faster. So timing is of course an issue. So what we ended doing was we were building 5G access rings that extend from their aggregation points in the hub ring. We were connecting the cell site using 2 DCSG for redundancy as well, where you will have fiber going in both directions along the ring. This will take up copper ports, which leaves a lot of room for enterprise customers to use. Each 5G access ring also has its own Grandmaster clock, enabled by connecting an antenna to our 9530XS. We also set up a secondary Grandmaster clock for redundancy purpose. The great thing about this was they didn't need to get additional equipment, just enable the TGM mode on our 30XS models. The remaining 30XS in the ring was set up as boundary clocks, which recover the time of day and PTP, and also distribute it to the next node. Because every node within the 5G access ring were our DCSG boxes, we were able to enable G.8275.1 profile and leave the existing 4G equipment stay with default profile. In the 2 use cases above, we used our S9530XS, disaggregated cell site gateway. The S9530XS is on the high end, where we can offer a high capacity, high port density with 25 and 100G ports. It got temperature hardened case, that means TP 76200 requirements designed for operation in GR 3108 Class 2 OSP. But not all application scenarios are the same. So after speaking with many carriers about their pain points, requirements, and combine that with our own experience in the field, we have decided to expand on our DCSG product families. We wanted to give more options and flexibility to our customers as they plan out their future network. We are actually extending our DCSG family in 2 directions. The first is the 9522XST, a RJ45 compatible DCSG with using the same CPU and Broadcom Corner X chip as the S9530XS. We have redesigned some of the hardware to make it more power efficient. Then the second is our newest offering, the S9501 series or DCSG Lite. These are a low capacity, low power consumption, and of course, low price DCSG. It's also got UV-Space in-house timing solution to enable Class C timing with the support to enable faster solution development. We have currently got 3 models for high, medium, and low port counts. All of our DCSG models have some things in common. The first thing is all temperature hardened to withstand -40 to 65 Celsius. All of our DCSG have front-facing ports, timing interfaces, and power supply, making them really suitable for outside plant cabinet installations as well as indoors. our power supply and fan are all designed to have redundancy, with the exception of 9501 16 SMT. Their fan and power supply are hot swappable as well. They all come with onboard BMC, deep packet buffering, and Class C timing. And this is the most powerful models, the 9530XS. And these powerful design are actually not only the port density on the 10 gig and 25 gig, but also enable 100 gig plus mixed support to actually ensure the dark fiber transportation with security protections. And the 22XST is based on the 30XD with optimized design on the support of extra 4x1G copper, which enables some of our customers, they would like to have 4G connectivity and 5G connectivity to the same cell-side gateway router or DCSG. And then majority their 4G BBU are actually using the copper interface to connect it with, which is different from the 1G SOP. Okay, and also on this box, we have further design optimization to reduce the power consumption from the 30XT as well. XS. And then about the 9501, 28, 18, and 16. These are the model that we redesign all the internal details, which actually optimize the overall design for timing, for power consumption, as well as with the Quantum UX Adapt, we optimize the port number and also optimize the overall price for some areas that price is very, very sensitive for the deployment. Okay. Here we are going to start looking into some other types of applications with the DCSG. This is an application that we are working with TIPS OOPT group. It's a wireless backhaul or microwave backhaul application, which doesn't get as much attention as it should. Actually, according to a GSMA report on mobile backhaul, the microwave is one of the most popular technologies used. Traditionally, the microwave backhaul is vendor-specific with proprietary internal interfaces. With what TIP is doing is separating parts of the microwave backhaul into components that can then adopt open and disaggregated architecture. So the microwave backhaul is separated into an outdoor unit or ODU and an indoor unit called IDU. The outdoor unit contains the antenna, radio, modem, etc. This part currently remains unchanged in terms of openness. The indoor units, however, is where DCSG comes into play. In this case, it's a disaggregated radio-aware cell-side gateway, which doubles as both a part of the wireless backhaul systems and the cell-side gateway. The DCSG aggregates and converts data from BBU to the ODU for the wireless backhaul, and the DCSG also aggregates ODU before going into the Ethernet aggregation network. So essentially, with one model, you can converge IP and microwave technology as well as provide capacity growth. This is very exciting for us as this use case starts to branch out the potential use cases of DCSG past the mobile cell site. And remember, we are using the same DCSG here. That means a carrier using multiple backhaul technologies can potentially use a single DCSG model. This means they are purchasing DCSG in bulk. The spare parts are the same, and it also makes their service team's job easier, thus faster servicing and less mistakes. This is a private 5G use case we are doing in Japan. This is a very interesting use case where as our DCSG has multiple functions within the private network. What we are building here is a network for wireless to premises or WTTP. The service provider would like to build a LAN for their customers. They have fiber terminal points throughout the city, but it would be very costly to dig additional fiber for the last mile. So they decided to use 5G RU for the last mile. It's faster, more convenient, and much cheaper than digging. Our DCSG is positioned within one of their local offices, where it aggregates the 5G RU and switches the data between BBU and user parent function before backhauling it to the core. In scenarios where the 5G RU doesn't have line of sight to a satellite, our DCSG would enable TGM mode and act as the timing source. Otherwise, it would be set as a boundary clock. In this use case, the same DCSG functions as the front haul, the backhaul, and the TGM in some cases. This type of private 5G application would be very suitable for our S9501-18 SMT, where you may not need too many ports or capacity, but still need the timing features and deep buffering to meet 5G service performance. The customer here was initially targeting wireless to home to provide on-demand video, live TV broadcasting, etc. But this type of architecture can easily be deployed around a stadium, within a factory or office building. So from the use cases we talked about today, the DCSG isn't just about lowering CapEx at the device level. There's another level of savings that comes from the flexible deployments, versatile usage, and efficient service. The great things about DCSG is that the potential applications keep growing due to the open and disaggregated nature of our DCSG. Our customers are constantly able to explore new applications with our solution partners. So it only makes sense for us to provide as many options as we can for our customers to foster their development and service innovations. Here is a comparison table for our DCSG. So everyone can easily classify by the major switch ASIC. So the 9500 series are using Broadcom Quantum AX, and 9501, the low capacity, low port count with cost optimization design are using current UX platforms. So you can see our DCSG family covers a wide range of port densities and capacities. We also have several node partners as well who are doing fascinating job providing network features. For those who want to understand or adopt open disaggregated solutions into their network with our partners EPS Global, we would love to help you explore your options. This wraps up my presentations. Thanks everyone for listening. I will send it back to you, Barry.
Thanks, Ray. That was excellent. There's a few questions there, so we'll get to, I'll bring you back in a minute or two. So just to wrap up. Some blogs on the website. Some interesting ones there. That tyranny of choice is quite good on the NOS side of things. We've a case study there as well on the first deployment of Cassini, and then some more on for service providers specifically. So yeah, Kira, I think there's a few questions there, is there?
A few questions that came in. The first question, sorry, thank you both for doing an excellent job there of talking about how telcos can build flexibility into their network at the cell site. The first question that came in, I think, is probably for you, Ray, because it's technical. It says, what timing profiles are supported on the cell site routers?
Oh, yes. Okay. So actually, all our DCSG are support completed timing profile, which including default profile 8265.1, 8275.1, and 8275.2. And also, all the platforms that we are offering today have the performance accuracy to fit Class C.
Okay, perfect. Thank you. There's one more there. Barry, this might be for you. How can customers get comprehensive support if there's multiple partners providing elements of the solution?
And that's disaggregation and open networking. There's always going to be multiple vendors. Using EPS, using companies like ourselves. I think I don't know anyone like us in the industry actually that has the relationships with the software vendors and the hardware vendors, and we've 28 global locations, so we can get that hardware with the software sitting on it into the locations that are desired by the customer. Like we're in proof of concept, Africa, in Asia, and these companies don't want to just use one software. They want to trial 3 and 4 software. So having the relationship with, say, DriveNets or IPI, IP Infusion, or Exaware or Volta Networks, obviously helps that, because we can get the trial licenses, and as well, obviously, getting the hardware to the location is the important thing for these guys. So okay. Yeah, using EPS, I think, is the answer.
Are you usually involved in those proof of concepts?
Yes, yeah, to a large extent. So I'd be the conduit between the SEs from the software side and the tier 1 or tier 2 telco we're dealing with. So you bring in who you need to bring in at the right times, so that the tier 1 doesn't have to deal with 3 or 4 different software vendors or 10 different system engineers. So yeah, we manage that basically for the customers.
Okay, perfect. We have several other questions there, but I'm quite conscious of everybody's time. I don't want to keep people on too long. So I've noted any other questions that have come in, and Barry and Ray can get back to each of you individually afterwards. So I guess we'll wrap that up for today. And I want to thank Barry and Ray again for joining us today for this latest edition of our Open Networking series. Thank you everybody else for joining us today, and we hope to see you again soon. Thank you. Bye.
Bye.
Thank you.